Hi, AP Calculus students. How you doing today? I'm going to use my writing tablet to go over the 3.2 quiz. If you have any questions after watching this video, let me know. Again, I'm not totally proficient with my writing tablet, and that's why I'm using it. I'm trying to get a little bit better, but I think I can do this well enough so you can understand it. Notice the instructions said must see all correct work for credit. There were just a couple instances for you where you had the correct answer, but I didn't see where you took the derivative, and so I did have to mark that. You will get 50% back for your corrections, and they're not available for problems left blank or obviously that were copied, but I didn't see that happen. So that was good to see. Okay, so let's take a look. Number one, find x equals c from -2 to 2, determined by Rolle's theorem for the polynomial given, or explain why Rolle's theorem cannot be applied. Okay, so when you look at this polynomial here, you can see it's continuous differentiable on a closed interval, right? All polynomials are. And so the next thing we just have to do is check our f of a, right, and our f of b and make sure that they are the same. So f of -2, there we go. When we put that into the equation, let's see, that's a 16 minus 16 is 0. There we go, f of b. Now you can see already that for f of 2, we're also going to get a 0 out. And again, f of a just has to equal f of b. It doesn't mean that they have to be 0, right? But they just happen to be 0 and equal to each other. Okay, so that means that somewhere the derivative, there has to be an x between -2 and 2 where the derivative is 0. So let's go ahead and take the derivative. Here we go, and that would be a 4x cubed. That's a 3. See if I can do that better. Minus 8x. Okay, a little bit of factoring here. Let's see, I can factor a 4x from each of these, right? And that will leave an x squared minus 2. There we go. So we'll set 4x equals 0 to 0, and we get an answer of x equals 0 when we divide both sides by 4. Notice 0 is in between -2 and 2, so that is one of the answers. Some of you left that answer off. And then we're also going to say that x squared minus 2 equals 0. So of course, when I add a 2, I get a 2. And when I take the square root, we won't forget our plus or minus. That happened for just a couple of you. So I just took a few points off. Plus or minus the square root of 2. Both of these also fall in the interval. So there's our two answers. Number 2, find x equals c for the mean value theorem for this expression. Notice it's rational from 2 to 4. Explain why the MVT can't be applied. This is where many of you lost your points. You said that the MVT can't be applied because you said that this was discontinuous at x equals 0. Notice though that x equals 0 is not on the interval from 2 to 4. So this expression actually is continuous and differentiable on this closed interval from 2 to 4 because 0 isn't in there. Okay, so the first thing I'm going to do is my f of b minus f of a. So let's just get f of a. F of a is f of 2. Let's see, we get a 0 out. And f of 4, that would be my f of b, is, let's see, that's 4 minus 2. That's 2 over 4 is 1/2. So when I do f of b minus f of a all over b minus a, let's see, f of b minus f of a is 1/2. That's a 2. There we go. Oh, I didn't want to say that. There we go. And 4 minus 2 is 2. There we go. And 1/2 divided by 2 is 1/4. Some of you had a -2. You just did your slope formula. You just weren't careful with the negatives. There we go. So the average rate of change on the interval from 2 to 4 is 1/4. Somewhere it is guaranteed that the derivative is equal to that. Let's find the derivative. I'm going to use the quotient rule here. So the derivative of the numerator is 1 times the denominator minus, I'm going to keep my numerator and multiply by the derivative of the denominator all over the denominator squared. And you'll see once you work this out, this is x minus x plus 2. And so you get 2 over x squared is the derivative. Okay, and we're going to set that equal to the average rate of change of 1/4. Lots of ways we can do this, but we could cross multiply. We get x equals, sorry, that was 8 equals. I wrote an 8, set an x. 2 times 4 equals x squared. And when I take the square root, not forgetting my plus or minus, I get x equals plus or minus the square root of 8. It can be written as plus or minus since 8 is 4 times 2, 2 square roots of 2, which most of you did. If you left it as the square root of 8, I took that because that is correct. Number 3, find x equals c for Rolle's theorem for this polynomial on -3 to 3, or explain why it can't be applied. A polynomial is continuous and differentiable, and it is on a closed interval. Let's check our f of a and f of b, right? So f of a, I think I'm going to sneeze here. Whoops, sorry. Excuse me. Excuse me again. F of -3, let's see, that would be a -27 plus 27. And again, f of 3. I'm going to get a 27 minus 27. So f of a does equal f of b. So somewhere it is guaranteed from -3 to 3 that the derivative, which is 3x squared minus 9, is equal to 0. So I'm going to add a 9 to both sides and divide by 3. And I get x squared equals 3. And when I take the square root, plus or minus, and I get x equals plus or minus the square root of 3. There we go. Next, number 4. For x equals c for the mean value theorem, for that polynomial from -2 to 4, or explain why the MVT cannot be applied. Polynomial, differentiable, continuous on a closed interval. Let's do our f of b minus f of a since it can be applied. My f of a, that's f of -2. Let's see, that's -2 cubed, -8 plus 1 is -7. And then f of 4, that's my f of b. 4 cubed is 64 plus 1 is 65, right? And so my f of b minus my f of a, 65, minus a -7. Just a couple of you were just not careful using the slope formula. And 4 minus a -2, right? So we get 72 over 6 is 12. There we go. That's the average rate of change on the interval. And somewhere the derivative is equal to that. Let's take the derivative. That would be 3x squared. And when we set it equal to 12, and we divide both sides by 3, we get x squared equals 4. And when we take the square root, we get x equals, and we won't forget our plus or minus 2. Now, technically, the answer is just x equals 2, because derivatives only occur on an open interval, right? And when you look at this interval here, -2 is at an endpoint, right? And so we can't include it because derivatives only happen on an open interval. So technically this is the right answer. But if you put this one also, plus or minus 2, it's really just a sticky point they try not to catch you on the AP exam. And so I didn't do that to you either. Now on number 5, find x equals c for the mean value theorem for this expression, the square root on the closed interval from -3 to 1, or explain why the MVT cannot be applied. So right here, really what's going on is I'm hoping, denominators can't be 0, square roots can't be negative, that you notice that if you try to put in a 0 here, that you're getting the square root of a negative number, which is imaginary and certainly not on this closed interval. So this function just at 0 is discontinuous, and that's good enough for me to say that the MVT cannot be applied here, because 0 is included in -3 to 1, and this function is not continuous there. If you want to get more technical without a doubt, you would tell me, because x squared minus 4 is under the square root, x squared minus 4 must be greater than or equal to 0, right? And when we add a 4 to both sides, we get x squared has to be greater than or equal to 4. And when we take the square root here, we don't forget our plus or minus, and we get x is greater than or equal to 2. But when we take the negative, then we have to flip the sign, that x has to be less than or equal to -2. And notice that that does not happen on this interval, right? It does for some, right? -3 is fine, but notice that -1 is not okay, right? And so it's not continuous on -3 to 1 at every point. So cannot be applied. Let's go down to 6. 6 cannot be applied either, though some of you really tried, right? Notice that, let's see if Rolle's theorem works here, right? From 0 to 4. I do see a problem, a denominator here. Notice that x cannot be 2 because the function is discontinuous, where the denominator is 0, and notice that 2 is in the interval from 0 to 4. So I cannot apply Rolle's. So I hope this helps you. Let me know if you have any questions.